Hi, everyone. Welcome back. Thank you, Jen, and thank you for the SciViz committee for inviting me to be here today. So this morning we already saw a few talks that we were talking about and supporting this close collaboration between art and science, mostly to help expert scientists communicate what they do, or better understand what they do and try to communicate that to others. So my talk is going to be more targeted to how can you communicate whatever you are doing if you're a scientist to the novel audience, to the novice audience, so to those people who actually don't know anything about what you are doing, and they actually are scared about science, medicine, or chemistry, or those kind of hard topics that are hard to understand. And also, so I've been a designer for many years, and I've been teaching design also for probably more than 18 years. But I have always been teaching design to designers, so I was trying to train the future generation of designers, until 5 years ago when I joined Princeton University and I started teaching design there, which is a very different type of students. So that's going to be the experience I'm going to share with you today. So my assumption coming today here is many of you are going to be scientists, researchers. You are probably used to seeing scientific posters in different conferences, or you probably create your own scientific posters. You are probably also used to seeing scientific illustrations in papers and so on. And you're also probably used to seeing graphical abstracts. However, I can tell who in the audience is not actually a scientist because your expression is looking more or less like that. So if you're not a scientist, probably, or most likely, some of those visuals look extremely abstract, and you're still trying to find out what the main topic that we're trying to convey was there. So this is one of the biggest barriers between people and science. I'm not saying that scientific content is not complex to understand, but most of the time it's not the content per se, but how the content is communicated. Many times scientific visualizations are very cryptic and are very abstract, and that generates an understanding barrier between people and the content. So this happens because visuals, when they are ineffective, they don't connect with the audience. They are too abstract, so people cannot relate to them. Visuals don't promote understanding and memory. There's nothing we can connect to what we are seeing to some knowledge we have stored from before. There's nothing familiar to us. And visuals don't direct or hold attention. Maybe they have very cryptic terminology that the words don't have any meaning for the audience. So one way to break that barrier to some extent is working with information design, that we actually had a talk also this morning related to this topic. So information design is the field that creates solutions that facilitate understanding in order to help people achieve their goals. So when information design is effective, when the solutions are effective, what they do, they make the abstract tangible and the unfamiliar familiar. So that helps people actually understand, relate the abstract concepts with something they are familiar with. They also show the hidden logic and the connection. So cognitively speaking, they require less energy to make sense of what's in front of them because information is already being digested for you. You know where you have to focus on. And lastly, they translate content, words or symbols into more easily to understand forms that can be easily perceived and used. So information design is also, we tend to associate it a lot with technology and a lot with probably visuals. However, information design examples are probably everywhere, and we interact with them much more often than we actually think. So we are used to seeing information graphics, like the ones in Scientific American, New York Times, and other publications. We are used to interacting with information design artifacts, like train timetables, I don't know, plane tickets. There are no more plane tickets anymore. But you used to. Different types of artifacts that communicate information and help us do things. We are used to also interacting with experiences where we can access information in a more in an easier way. For example, when you go to a museum and you see an exhibit about a scientific topic, but you actually leave the exhibit knowing a little bit more than before. And more recently, information design problems have become much more complex and less concerned with the design of tangible artifacts or the design of isolated things, but more thinking systemically about a problem and trying to design a service that helps a person along a journey, not only about specific artifacts, but different parts of that journey. So probably some of you are thinking, yeah, we know these artifacts, and you are wondering, or maybe you think, how do these people work? What happens with them? Are they in the shower and then they have an idea and then they start creating a visualization? There are so many different theories and models about how designers work. The reality is many designers work in different ways, but there's also a common thread about a common way or a common process that most information designers follow. So without going into too many technicalities yet, we can divide this information design process into two big stages. The thinking part, where you are making sense of the content, and then you are conceiving the ideas, and the doing part, where you're actually executing those ideas that you conceived before. So if you go a little bit more technical and a layer deeper than that, we start to see the different tasks and activities that are involved within each of these two big stages. So you're starting to understand that the process is not first so cryptic, and also it's not like the designer jumps into a computer and starts designing. Information design has a strong focus at the beginning of the process because it involves figuring out what to do, understanding the content, understanding your audience, understanding what you need to communicate. So that's where we say that in information design, there's a strong emphasis at the beginning, and not so much at the end as many people think. Oh, I just learned the tools and I know how to create an effective visual scientific visualization. Not so much. There's a lot about figuring out what you need to visualize. So why are you bringing this today? So the design process has increased its role in importance lately because there has been probably an increase in the interest of design and information design beyond design schools. You're seeing that science is very interested in learning about information design, business, politics, so different disciplines. So all this, to some extent, has made design education broaden and not being only taught at design schools, but actually now many different institutions have started to teach design, different flavors of design, different permutations, but most of them have design courses, although they are not design schools like Parsons or SBA. That's the case also of liberal arts education, and that's kind of what we are going to be focusing in the rest of the talk. So as I assume some of you know, Princeton University is well-known. It's a well-known liberal arts education, not precisely for its design strength, but for probably its science and different discoveries, many Nobel Prizes coming from Princeton University. And also it has 36 different majors, but there's no design major. However, in the last 5 years, there have been created many different design courses about design thinking, information design, creativity, UX design, and so on. These courses are quite different from a Parsons course or a more traditional design course because the students in Princeton, most of them majoring in some sort of science, the ones who are not majoring in history or psychology. So this means that the design courses are quite different. They have to be very self-contained. They are 12-week long courses that you need to be tackling very frame problems. You can't go in very much depth, and the courses don't build on each other. So that make the approach to teaching design very different from a traditional point of view if you are used to teaching design. Also because the students don't have much time to devote to design because they are focusing on the major. So in this context, I created in 2015 this class called Design for Understanding, which my goal was to teach science majors, actually students from across all departments at Princeton, from freshmen to seniors, how could they communicate science into a clearer way, either in their thesis, in their papers, into day-to-day life, whatever they want to do. So to do that, because Princeton students, again, they don't have a strong design background or artistic background, the course is not focused on technical skills or so much on learning software, but actually students are learning the process and the science behind the field. So they learn how to make sense of information, they learn different psychology principles to help them understand how we perceive the world and how they can support that with design. They, of course, learn some design principles so they can start translating content into visual form. And they learn visual thinking to start learning how to work together with others and externalize their thinking process. We do this through a combination of different things. It's a very hands-on class, combining mini lectures, visits to museums, different organizations, in-class exercises, peer feedback. But one of the most interesting parts to me from the class is like the students act as the content experts. I don't choose the topics, they choose the topics they want to work with. That means that they just have to focus on learning information design, and they already know the content they are working with. And this varies from quantum computing, the effects of caffeine, Bitcoin, the more kind of economic related, ones majoring in economics, synaesthesia, from, I don't know, chemistry, different topics. Last semester, we decided to do an experiment because the class has been growing. So we have two different groups. One that follow what I just said. They could choose whatever topic they wanted to communicate and work with that while learning information design. And we have a second group of students in which we told them, you need to communicate quantum computing. You're going to be learning information design, and your topic is going to be quantum computing. They were interested in the topic. They didn't know much about the topic. So just keep those two things in mind. So now I'm sharing what happened after trying this. If we started to compare what happened with Group A, they were the content experts, and Group 2, Group B, the quantum computing group. So this was a bad idea, in the sense like they were trying to learn two hard topics at the same time, quantum computing and information design. So we decided the results between that group and the other one were quite dramatically different. It was too much to learn at the same time. So our conclusion was either you teach how to learn about one hard topic, quantum computing only. Once that's understood, you can go to the next one, to information design, and at the same time working with an expert. Thankfully, my teaching assistant was doing his PhD in quantum computing, so he was the content expert in the class. So I'm just going to briefly show you one of the students' projects, not because it is visually strong, but you can see how by starting to learn information design, rational, and a different way of making sense of information, he was able to come up with what is to me a very strong and clear analogy to explain a type of quantum computers to a very novice audience. So he had to explain what a trap ion quantum computer was. So he came up with the analogy of equating this type of quantum computer to a classroom. So don't ask me to start explaining what a quantum computer is, because it's beyond my expertise. But hopefully after seeing these few slides, you're going to see that you're able to understand what the classroom is, what the students are, that they say things, that there's a teacher, that when a student wants to say something, they raise their hands. And when they are looking at their phones, that's a bad thing, that's an interference. So, okay, we have this in mind. How can we compare that to this type of quantum computer? Even if you're not an expert, Okay, there are things within something. These ions are trapped. There are magnetic fields, and those are called qubits. There's a laser, which is similar to what the teacher does, that controls these things. When one is excited, then there's an external interference. This is just the beginning. So hopefully, I mean, you will not become an expert on quantum computer, but you get the sense of how, by having an analogy, you help slightly bridge that gap between something really complex and something familiar. So why it is so hard for information designers to communicate these things if we are meant to be experts in coming up with those analogies? So there are a couple of variables that are in play here. While information designers, we have very high sense-making expertise, and we have high awareness about who our audience is, we are not familiar with the topic, with complex topics. This means that our ability to explain a topic to someone else is really hard. On the other hand, content experts don't have information design expertise. They usually are not too aware about the audience needs. They are really, really familiar with the content, but sometimes when you are very familiar with the content, it's really hard for you to go back to the basics and to explain that content to someone who knows absolutely nothing about that. So I would say that as familiarity increases, the more we know, the harder it is to convey something in a very clear and simple terms. That's why, so this is just a brief analysis that if you know a lot about information design only, you're going to create very visually, pleasingly aesthetic results, but content-wise, they maybe are going to be weak, or maybe are going to be inaccurate. While if you know a lot about something, but you don't have information design expertise, the results are going to be really cryptic, perfectly accurate content-wise visualizations, but they are going to be really hard to understand by the audience. So what I'm actually proposing, similar to actually, I think one of the talks in the morning also pointed this out, it has to be a partnership between information designers and content experts. Not so much I draw something and then I show it to the content expert, but actually working together at each stage of the process. So figuring out together how the visualization should look like, and also taking into account the audience needs. We always forget about the audience. We always forget about who the audience is, what language do they speak. Not language about English, Spanish, but terminology-wise. So paying more attention to those things. And just to leave you with you guys, 2 key recommendations if you are thinking of teaching information design or learning information design, why not? So the first one, yes, do work closely with content experts, not only reading their papers or calling them from once in a while, but actually shoulder by shoulder, asking them, what do you think about that? Asking them questions, why is this, why is not that? Trying to understand what the person is trying to say. And the last one, you're always designing for someone else. Bring that someone else into the class or closer to you. Test whatever you're doing with the audience of that visualization. Otherwise, for us, it's always going to be easy to understand. We are creating that. But you're not designing for you. You are designing for them. Thank you.